I think it's possible for us to cut down the amount of time we spend doing automated testing of software by over 90% without reducing the quality and consistency and completeness of our testing. Today I'm going to introduce to you a new software project called testtrim that is attempting to do this. This is a project that is still under development, but I'm hoping to share a little bit about the development so that I can get input and feedback from the community, as well as entertain and interest people with the technical work that's going on. Let's take a little bit of a look into what I'm planning to do, and then I'm going to demonstrate to you the software in a working state today, in a working but extremely limited state today. So here's a side-by-side view of some of these basic math functions and some basic test cases for them. And I think that as a human, it's really easy for us to identify that this test add function tests the functionality of this add method, and this test add decimal tests this add decimal function, and so on. So the idea behind testtrim is if we were using a test coverage tool, a tool that was running these tests and monitoring what functions and files that they touched and executed while they were running, we would be able to know that test add uses the add function and test add decimal uses the add decimal function. And then if we combined that with a source control diff, for example, here a git diff, we would be able to see that while we were making this change, we did not modify the add function. And so we know that we don't need to rerun the test add test. That's the basic concept here, is that we're going to use a combination of coverage data that's gathered on tests and Git or other source control management systems change management, merge the two to be able to see what tests we actually need to run in what situations. Let's take a look at testtrim working in this demo project. So this project has basic ops, which has a bunch of really simple mathematical functions, adding, subtracting, multiplying, dividing, very uninteresting functions. And then it has some slightly more complex functions like a Fibonacci sequence and a factorial here that use some of those basic operations, the addition, the subtraction, and the multiplication. So we're going to run it first of all in a clean checkout of main. Okay. So I'm going to run it with a fairly verbose output here so that we can see what tests are being run. When I run this for the first time, it's going to say, I didn't find a base commit identified with coverage data to work from, and then it's going to execute every test in the project. So if you take a closer look here, we can see that we're running a test out of source lib.rs, and we're running sequences, tests, test Fibonacci, for example. Now, if I pop into my editor and I make a change to one of these tests, factorial of 0 and the factorial of 1 is -1. Then when I run testtrim, what it's going to do is, ignoring the fact that the test failed, that's kind of the irrelevant thing. Obviously, the test failed because that's not the right definition of a factorial. But it's able to look at the previous commit of data that I had just run. And now it says that I have only 2 relevant test cases out of my total 8 test cases in this suite. And I'm going to run that 25% of those tests. And then, of course, they're going to fail. There are basically 3 parts to testtrim's functionality today. One is when it runs tests, it runs them with independent coverage output. So the tests are instrumented, and then they provide information about what functions and files they executed on a per test basis. 2 is we take a look at, using the source control system, what changes have been made since the last time we ran a test. And 3 is we identify the last time we ran a test by saving that coverage data into a database. Between all of those pieces, testtrim is able to target what set of tests need to be run for a specific change. Let's run a little bit of a demo with a larger project. If you've never heard of ripgrep before, you really should have. It's an amazing tool. It acts as a replacement for grep, but it is so much faster. And it is one of the few test projects that I've been using to run testtrim against to see how effective it's going to be. So what we're going to do to give you a quick demo is I'm going to take a look at the git log for ripgrep. Then I'm going to go back a couple commits here, and we're going to work with this 8bd commit. I'm going to run testtrim here. This should run against all tests because I haven't stored this data in my database yet. Excellent. We were able to successfully run all the tests. Now I'm going to check out master. And if I run testtrim again, it's going to do its computation based upon that 8bd595 commit. And here it identifies that now in the couple of commits since then, I've made enough changes that I need to rerun 434 out of 1087 tests for 39% of the tests. So there's some examples of testtrim running. So how effective is it? Well, my approach for analyzing how effective this solution is to work with projects that are open source that have a good commit history and run testtrim against them to see what kind of outputs I get, how many tests need to be executed on a per commit basis. Right now, the data looks pretty promising, but there's more analysis to be done, of course, and more testing to be done. The two major ones that are test samples for me are ripgrep and alacrity, a terminal emulator. I've gone into some depth with alacrity. What I've been able to discover is analyzing the past 100 commits from the project, excluding a few commits that at the time testtrim wasn't able to run or wasn't able to operate on average, each commit only required running 8.4% of the test suite. And the P90 of tests to run per commit, so this means that 90% of commits required this many tests or less, was 38.9% of the tests. So I think that this indicates, even though it's in an early stage of development with a lot of limitations and restrictions, there's a really interesting potential gem here. If the average test to run per commit can stay around the 8 to 10% level, that does mean 90% of tests don't need to be run. But let's talk about the limitations. Where is testtrim at as a project? I imagine software somewhere on like a spectrum from twinkle in a developer's eye to Microsoft Word that has been around for decades. Testtrim is closer to twinkle in a developer's eye than it is to an alpha software release. It probably even hasn't completely reached the point of proof of concept. I think it's at the stage of concept is interesting and there isn't any strong evidence against it yet. So it's not proof of concept, but it's like hypothesis of concept. Yeah, I'm going to say it's at the hypothesis of concept stage. The larger requirements for testtrim to be a really useful tool are going to be supporting multiple different platforms. So not everybody's doing Rust development, but I don't see any reason that the same concepts couldn't apply to, for example, JavaScript development. But I don't want to dig too much into those. I don't want to get really broad in testtrim's capabilities before I get really good at some of the smaller scope. But the major thing, right, where testtrim is really going to add a lot of value is if I can get it working with distributed testing environments. So when you have test code running on one system and it's operating a browser, and that browser is touching front-end code, and that front-end code is touching back-end code, and that back-end code is touching database code, is it possible to use the same concept of coverage-based test targeting in a complex distributed environment? I think it's going to be possible, but quite difficult. That's where testtrim is really going to unlock a lot of value, because those tests are the ones that are going to be really expensive for projects to run. That is a run through of testtrim, what the concept is, what the software does today, and some of the things that I think are blocking it from being a usable project and going forward and revolutionizing automated testing. I would love it if you would subscribe to this channel to see those future updates. I think they're going to be really interesting content. I'm really excited about this project. I think it has a lot of potential to be really valuable for people, for businesses, for projects. So please subscribe, come along and go through this journey with me. Provide me your feedback, your insights, and your input, because the more I know about what people think about this project, the more I'll be able to tailor it to what people's real needs are and real challenges, as opposed to just working off of my historical challenges. Thank you for watching, and see you later.